Hello students, welcome to my class. Today I am going to discuss few questions related to your chapter number 3 and the pattern is completely CBSE pattern. Okay my friend, so let's start. That is the first question. Listen carefully what is given here. This is a 1 marks question. What would be the IUPAC name and symbol for the element having atomic number 120? Do you remember during my lecture I have discussed that is if the atomic number is 120 then it for 1 we know that is un, for 2 that is bi, for 0 that is nil and we will add IUM, remember. So the name of this compound is my friend, wait for a moment, unbinilium. Unbinilium, that is the name and the symbol is U, B and N. U, B and N, remember. So this is a single marks question, so we have to reply within 10 to 15 words, short reply, short marks, so reply should be within around 10 to 15 words, enough, maximum 20. Now I am going to rub this part and we'll discuss the next question my friend. Wait for a moment what I am telling. The next question is, what is the basic theme of organization in the periodic table? As we know, we organize the elements having same property. That is, to systematic study of the elements and their compounds, we need to organize the elements in the periodic table. So, what is the basic theme? Systematic study of the elements, of the properties of element and the properties of their compounds. We need a periodic table so that we can easily understand each and everything, physical properties, chemical reaction involving, then physical nature, chemical nature, properties of their compounds also. Clear to you? This is a single marks question, so you have to reply this question only around by using only 20 to 30 words. Clear? Now I am going to rub this part and we'll discuss the next one. Wait for a moment my friend. That is, let's move to the question number 3. What is given here? Look at, this is a 2 marks question. So now you need slight explanation in this case. So by chemical reaction with water, that Na2O is basic oxide and Cl2O7 is an acidic oxide. Now how to solve this question? Listen carefully. That is, as we know, when Na2O is dissolved in water, it forms NaOH. That is, it has OH ion. That meant to say we people balance them. We can say that is Na2O is basic oxide. Clear my friend? When we dissolve Cl2O7, clear? Cl2O7 in water, then what do we observe? It forms, that is my friend, HClO4. Now what to do? Like this, balance them, HClO4. That is, it contains H plus ion. So we people say that is Cl2O7 is acidic oxide. Am I right? Cl2O7 is acidic oxide. This is the thing. Basic and acidic oxide. Clear to you? So I think you can easily answer such type of questions. Now I am going to rub this part and we'll discuss the next part of the question. Next question, what? Wait for a moment. Now, question number 4. Which element do you think would have been named by Lawrence Berkeley Laboratory? That is lawrencium. Clear to you? Lawrencium having atomic number 103. And what is Seaborg group? Seaborgium. What I am telling, that is Seaborgium, having atomic number Z is equal to 106. As I told you, this chapter is completely theory based. If you have a command over the theory and complete explanation, then you can easily solve the questions related to your school examination. Clear? Again I am repeating, Lawrence Berkeley laboratory, that is Lawrencium, and Seaborg group, that is Seaborgium. Clear to you? Now I am going to rub this part and we'll discuss the next question, my friend. Wait for a moment. Let's move to the next question. What is given here? What do you understand by isoelectronic species? Clear? Name the species that will be isoelectronic with each of the following atom or ions. What do you mean by isoelectronic species? Tell me. Isoelectronic species. Clear to you? What are isoelectronic species? That is the species having same number of electrons. Species having same number of electrons are called isoelectronic species. For example, if I write Na plus, if I write if I write Mg2 plus, then neon Ne, then F minus, clear to you, then O2 minus, N3 minus, so on. Then what do you observe? In Na plus there is 10 electron, in Mg2 plus there is 10 electron, neon there is also 10 electron, fluorine minus 10 electron, O2 minus 10 electron. In each and every case, what do we observe? That is, they contain 10 electron. That means to say, species having same number of electrons are called isoelectronic species, my friend. So for this question, that is the explanation. Now again here is given, that is, name the species that will be isoelectronic with each of the following atom or ion. This is a 3 marks question. So there is a requirement of explanation. Now here is given, that is isoelectronic with F minus. As we know, F minus contain, my friend, 10 electron. Yes sir, if it contains 10 electron, then definitely the isoelectronic species will be neon, will be O2 minus, will be N3 minus, maybe Na plus, maybe Mg2 plus, maybe Al3 plus. Clear to you? Now argon, as we know, argon contain 18 electron. So the isoelectronic species in this case, tell me, that is argon, we people can say K plus, Ca2 plus. Clear to you? Then K plus, Ca2 plus, then Cl minus, then sulfur 2 minus, etc. Now Mg2 plus, that again is contain 10 electron. In this case, same explanation, neon, O2 minus, N3 minus, that is Na plus, so on. Now rubidium, wait for a moment, Mg2 plus 10 electron. Now rubidium, you remember this, rubidium belongs to group 1, that is lithium, sodium, potassium, rubidium, cesium and francium. What is the atomic number of rubidium? If it is 19, that is 35. Remember this? Then this one, what is the magic number? 3, 11, that is 2, 8, 8, 18, 18, 32. So if you do not remember the atomic number of element more than 20, then you have to use this one. As I told you earlier, 2, 8, 8, 3, 8, 8, 3 plus 8, 11, 11 plus 8, 19, 19 plus 8, 9, 8, 7, that is 19 plus 18, that is 30, 37. Clear to you? Not 35, that is 37. Wait for a moment. So rubidium has atomic number 37 and there is a plus. So definitely rubidium contains 36 electron, my friend. Clear to you? Now which contain that is the 36 electron? Simply strontium 2 plus. As we know, strontium has atomic number 38. 2 plus, that is it contains 36 electron, my friend. Clear to you? Now if I write here Br minus, as we know bromine has atomic number 35. 35 plus 1, 36. If you do not know the atomic number of bromine, the best one is, as we know, fluorine, chlorine, bromine. Clear to you? 9, 17, 17 and 18, that is 35. 1 electron, 36. So the isoelectronic species of Rb2 plus is strontium 2 plus and Br minus. Clear to you? I think I have given the complete information related to the isoelectronic species. Clear, my friend? Now wait for a moment. Let's move to the next question. What is the next question? This is completely theoretical question. What is the significance of the isolated gaseous atom? What is isolated? That is, it is free from other atom. That is, it is in a free state. Suppose if I write Na, that is in a solid state, first convert it into the gaseous state, that is, this is the isolated gaseous atom. Now you can easily remove an electron from this, and this is known as ionization energy. That is the energy required, that is you can say plus IE like this. The energy required to remove an electron from the outermost shell of an atom. So isolated gaseous atom, that is atom which is free from other atom. We do not require more energy to release that atom. This is in a free state. And in case of ionization energy, we use the isolated gaseous atom. That is, what is ionization energy? The minimum energy required to remove an electron from an atom in gaseous state. This is the case. Here minus electron, you can write there is a release of electron take place. Clear to you, my friend? So this is the condition, and this process is, we people know, endothermic process. Due to this reason, I have written here minus IE. If it is exothermic process, then I will put here plus sign. Clear to you? This is endothermic process. So in case of ionization energy, we write here that is isolated gaseous system. Similarly, if I put here Cl, that is again in a gaseous state, we do not need to convert it from solid to gas. Now if it gains a electron, there is a release of energy take place. If there is a release of energy take place, then we can say this is known as electron affinity or electron gain enthalpy. Here the release of energy take place, that I have, that due to this reason I have put plus sign. So in this case it can be written like this: delta EGH is negative. Negative sign proves that this is a exothermic process. Generally the electron gain enthalpy we find the exothermic process, but during my lecture I have discussed its value may be positive, may be negative, or may be zero according to the situation. So the electron gain enthalpy is possible, that is, the definition is the energy released when an isolated gaseous atom contains gain one electron. So the isolated gaseous system, that is completely the atom, it is in free from other atom, and this term is used in case of ionization energy and electron gain enthalpy, my friend. Now what is given here? Ground state. That if a atom is in stable state, that is ordinary state, that is known as ground state. Suppose if I write here hydrogen, as we know hydrogen has atomic number 1, 1s1. The electron reside here, And if you want to remove that electron from here to the second orbit, then it comes into the excited state. This is excited state and the ground state. Ground state, that is atom is in stable state, is normal state, is known as ground state. But in dealing ionization energy and electron gain enthalpy, we use what? Isolated, the term isolated gaseous atom. Endothermic process is, my friend, again I am repeating, endothermic process is that in which there is a requirement of energy. In case of ionization energy, it is a endothermic process because there is a requirement of energy to release the electron. And in case of electron gain enthalpy, it may be positive, negative or zero according to the situation. Here in this case, the energy release. In general case, we find that that is the exothermic process, but the case is not same. It may be endothermic. During my lecture, I have discussed this thing. Clear to you? Now, I think you can easily define this question in your words. Now, question number 7. This is GKGS type question. Now, tell me. Identify an element with 5 electron in the outermost subcell. 5 electron in the outermost subcell. That is, they are talking about nitrogen, like this 2 and 5, phosphorus 2, 8, 5, nitrogen, phosphorus. This all belongs to that category which contain 5 electron in its outermost cell. So we will tell that is group 15 belongs to, that is this statement, 5 electron. For example, nitrogen, phosphorus, arsenic, antimony, bismuth, etc. Now identify the element that tend to lose 2 electron. As we know, if I talk about the group 2 element, group 2 like magnesium, calcium, strontium, barium, they all have, look like this, 12, 2, 8, 2. They have a tendency to lose 2 electron to gain stability, to gain nearest most inert gas configuration. So it can be written like this, Mg2 plus, my friend. I think you can easily solve such kind of question. Now let's move. Identify the element that will gain 2 electron. As we know, generally if I talk about the group 16 element, that is oxygen, sulfur, etc., that is it gains 2 electron, because if I talk about the oxygen, it can be written like this, 2 and 6. How many electron it required to gain its stability? So 2 electron. So in this case, we will say that is they gain 2 electron and convert it O2 minus, H2 minus, so on. Identify the group having metal, non-metal, liquid as well as gas at room temperature. As we know, if I talk about group 17 element, in group 17 element, fluorine, chlorine, bromine, iodine. As we know, iodine has a solid, iodine is solid in nature. It has a metallic property, because we know when we move down the group, the metallic nature increases and non-metallic nature decreases. Bromine is liquid in nature, fluorine and chlorine gaseous in nature and are non-metals. Clear to you? So group 17 contains metal, non-metal as well as gas at room temperature. Clear to you? Now I think you can easily solve this question. It will help you a lot. Now I'm going to rub this part and we'll discuss the next question, my friend. Wait for a moment, give me few seconds. Clear? What are the various factors given here? What are the various factors due to which ionization enthalpy of the main group element tend to decrease down the group? What is given here? What are the various factors due to which ionization enthalpy of the main group element tends to decrease down the group? As we know, if I write here lithium, sodium, potassium, rubidium, cesium and francium. Clear? when we move down the group, what do we observe? That is size of the atom increases. So the first factor, size of the atom. If the size of the atom increases, for this lithium, that is for lithium the atomic number is 3, we can write 2 and 1. For sodium the atomic number is 11, it can be written 2, 8, 1. That is, the distance from the nucleus increases. If the distance from the nucleus increases, then they feel less attraction. So we can easily remove the outermost electron. So first factor, size of the atom. If easily removed, then it requires less energy. So down the group, the ionization energy decreases. First one is size of the atom. Second one is, generally we say, screening effect. Screening effect, but this effect dominates, listen carefully, this effect dominates in when we move along the group, along the period, my friend. That is from lithium to beryllium, beryllium to boron, boron to carbon, carbon to nitrogen, so on. But down the group, size of the atom. Second one is, this one not completely dominant. Second one is addition of extra cell, addition of extra cell, clear to you? That is, this is K, this is L, and this is M. In K only KLL, K and L, but Na and Na, KLM. So addition of extra cell take place. And the third one is, my friend, nuclear charge. As we know, if you move down the group, that is the impact of nuclear charge also. So the basic factor is the size of the atom and the addition of extra cell. But in case of skinning effect or shielding effect, that is the involvement of effective nuclear charge. This factor basically used when we deal the ionization energy along the period, my friend. So basic 4 factors are there, but among them these 2 factors, the size of the atom and addition of extra cell, is the important. Clear, my friend? Now I'm going to rub this part and we'll discuss the next one. Wait for a moment. Clear? How would you explain the fact that the first ionization enthalpy of sodium is lower than that of magnesium? First ionization enthalpy of sodium is lower than that of magnesium. Clear? As we know, sodium has atomic number 11. It can be written like this, 281. That is, or the subcell wise 1s2, 2s2, 2p6 and, my friend, 3s1. This is the case. Now look at 3s1. It contains only 1 electron from its outermost cell. So we require very less amount of energy to release the electron. That is, Na converted first solid, it converted to in gaseous form, then there is a release of electron take place easily and it forms Na+. But if I talk about the magnesium, magnesium has atomic number 12 and the electronic configuration is 282. Clear? Like 1s2, 2s2, 2p6 and 3s2. Clear, my friend? Now in this case, that is the completely filled subcell, and along the period we know size also, my friend, decreases. If size decreases, that is increment of effective nuclear charge. So it is not easy to release the electron. So in case of Mg, we require maximum amount of energy, that is solid. It comes into gas, then it forms Mg plus 1 electron, that is the ionization energy 1. Clear to you? This is the case. So we can say easily that is Na plus, that is Na, the first ionization energy of Na is more than that of Mg. But what about the second ionization energy? When second ionization energy, that is Na is in plus state, that is Na plus, now it has 2 and 8 electron. Now it is in complete stable state. Clear to you? If it is in complete stable state, then we require maximum amount of energy to release this inner shell electron. So it will have high value of second ionization energy. Clear to you? Again I am telling, it has high value of second ionization energy. But if I talk about Mg plus, because it will now have KLM. Clear to you? 281, one electron in the outermost shell remaining, because it has 2 electron. Now we can easily remove this electron, because after that it will gain the stable electronic configuration. So sodium has first ionization energy less than magnesium, but second ionization energy more, because after losing one electron it acquired the inert gas configuration, nearest inert gas, stable configuration. So it is hard to release the electron from the inert shell. Clear to you? I think now you can easily solve such kind of questions, my friend. Now let's move to the next question. Wait for a moment. Now the next one is, read the data what is given here, that is 520 7300 minus 60, 419 3051, that is the value of first ionization energy, second ionization energy and electron gain enthalpy. Clear to you? Now what is given here? The least reactive element. Which one is least reactive? High value of ionization energy should have high value of ionization energy and positive value of electron gain enthalpy. Now in which case high value of ionization energy, look at this one and positive value. So we will say fifth one is less reactive. Clear? Now the most reactive metal. What is the most reactive metal, my friend? That is low value of ionization energy will be the most reactive. Look at 419 is the low value of ionization energy. So for question number 2, second is the correct option, my friend. Now the most reactive non-metal, my friend, tell me the most reactive non-metal. This one, as we know, the reactive non-metal will have high value of electron gain enthalpy, negative value of, look at which one has this one. So the third one is high reactive non-metal. Clear to you, my friend? Okay, now the next one is the least reactive non-metal. Now least reactive non-metal, my friend, tell me, that is it has negative value but high value of electron gain enthalpy. So we will say that is the fourth one is the answer. Clear? Now the metal which can form a stable binary halide. Which will form a stable binary halide? Tell me, which will have, tell me, my friend, which will form, that is stable binary halide of the formula MX2, and the metal which can form predominantly stable covalent halide of the formula MX. Now think on it, which will be the answer in this case, my friend. I am leaving this question for you. Tell me, can you do for it? Look at 527, just a sudden increase. So it will form, that is one will form the covalent halide, that is MX, and MX2, which one? That is the sixth one, will form the covalent the halide of the formula MX2. Clear? So for E that is 6 and for F that is 1. Clear to you, friend? So I think now you are very much familiar with this type of question and it will help you a lot during your examination. So friend, that is the end of my lecture. We will meet again with new topic. Thank you so much.